Hello and welcome to 8 Keys to Achieving Success with Artificial Intelligence in the Supply Chain. This is an educational session where we're going to walk through the technology fundamentals, the data requirements, and network strategies for successful AI implementations, and then help supply chain professionals to identify the best use cases for artificial intelligence. My name is Michael Levins, and I'm Group Editorial Director for Peerless Media Supply Chain Group, which of course includes Logistics Management Magazine and Supply Chain Management Review. And I'll be your moderator for this session. It's being brought to you by One Network. Now, as we've been covering in the pages of Logistics Management and Supply Chain Management Review, and we're hearing in a lot of conferences we attend, there's a lot of buzz around artificial intelligence and supply chain management, and we believe that the move for supply chain professionals to put AI to work is inevitable. In fact, many of us may be using some level of AI already to improve both overall supply chain efficiencies and provide optimized supply chain decision making. That's where this is all heading. And the market is well aware that there's huge potential as AI offers significant benefits across the supply chain, but it's also very important to keep in mind that that potential is based on solid fundamentals that consider the scale and dynamics of today's business networks. Now, success in AI also in supply chains is heavily dependent on information accuracy, data timeliness, and the selection of the correct AI applications. Now, today, Joe Bellini, and Joe is author and supply chain AI strategist, and he's also Chief Operating Officer at One Network. And Joe's going to touch on those important fundamentals that supply chain managers must grasp and really truly understand in order to maximize business results from AI implementations. And Joe, we're thrilled to have you with us today, and you've put together just a terrific presentation for us today, and I'm looking forward to it as well. Now, just a quick heads up before we get started, we are going to have time for a Q&A session after Joe goes through his presentation. So please make sure to submit your questions at any time, and we're going to get to as many of those questions following Joe's presentation. Also, too, the folks at One Network have some terrific resources to download as a PDF. And, of course, we always want your feedback. And if there are any technical problems, of course, just hit that F5 on your keyboard, and it will refresh that browser to make sure everything's up and running. So again, just quick housekeeping. Make sure to shoot all those questions over while Joe's going through his presentation. We're going to get to as many of your questions today as we possibly can in the time allotted. So let's get started, Joe. The podium is yours.
Great. Thank you very much. I will jump right in. Just to introduce the subject to everyone we have on the line, and to give you a bit on my perspective on this. If you look at where supply chain is now in relation to artificial intelligence, what I'm going to discuss today is about supply chain networks as they relate to artificial intelligence, because it's the combination of the ability to put in a network operating model in your supply chain combined with AI that's going to release the value that's trapped in your network today. And so over the next 30 to 35 minutes, I'll walk you through an approach as to how the technology has made that possible today and how you can go after and achieving those results. And to give you a bit of a perspective on that, back years ago, I wrote some of the original patents on multi-enterprise supply chain planning. And the technology advancement at the time that made that possible for us was in-memory processing. Without the in-memory processing, I couldn't look simultaneously at demand, material, and capacity, and therefore couldn't make a holistic run across the full supply chain. So it was that technology advancement that allowed us to release the trapped value in planning. Now, execution is more complex. Planning, of course, occurs further away from execution. Once you're into execution, you're dealing with a lot more variables. And so it required an advancement from supply chain to supply network to really start to get at the ability to get in and handle all the issues, exceptions, and problems that occur from an execution perspective. But the volumes are large enough as you get closer to execution that you need to mix the newer network architectures in with artificial intelligence. It's that combination that allows us to unlock the trapped value in the supply chain network. So that's what I'll be talking about today. And if you look at the analysts, Gartner recently came out with a Magic Quadrant on supply chain networks. And that was encouraging because the recognition that this is a new and advanced software category beyond what ERP has been able to provide really helps us get at solving this problem. Just taking the old monolithic batch-oriented architectures and trying to solve network problems really wasn't able to unlock the value that's out there. It led to a lot of custom development, which I'm sure any of you that are looking at upgrades and even re-implementations now with your ERP vendors, it's causing you a lot of headaches. And not even mentioning trying to move to the cloud if you're on-prem at this point. So there's a lot involved there in recognizing that just like before, when we created a new category called supply chain planning, and that really took hold of the market and created some great value. Now there's, as verified by Gartner, a new category that will displace ERP in certain areas and operations across the network. And so combined with AI, it becomes a reality. And so that's what we'll be addressing. These models are out there. The Ubers, the Airbnbs, the Alibabas, these proof points are in the market. Many of those tend to be a little bit more B2C. We're talking more about B2B here. But this is reality, and it's out there and generating value today. And so the first step in looking at new technology is making sure that we're not putting in technology for technology's sake. And I think AI, and I recently just finished a certification program at MIT on artificial intelligence and machine learning, and a lot of the issues around AI initially were, are we really solving true business problems, or are we just looking for ways to apply the technology? And so I wanted to walk through the current business problem that needs to be addressed, because it really has never been addressed. Even with all the customization we tried to put in to the old ERP architectures, the problem still wasn't solved. So if we start to look through these endemic issues, the current enterprise-centric software really isn't designed for network business operations. It never was. It was designed as hub and spoke. Networks, as we know, is a many-to-many architecture, not a one-to-many. And so you need to have an architecture bottom-up designed for that network business operation. The planning to execution workflow within the enterprise and across the tiers employ multiple disconnected algorithms and optimization engines. So the fact that everyone's really trying to sub-optimize within their own tier or their own echelon really causes us to trap value. And if you're running this way, this of course requires armies of planners, because each echelon, each tier is going to plan for themselves, and therefore everyone else needs to react to that, and they need to plan for themselves. And so then you end up with a lot of staffing in areas that really shouldn't be trying to sub-optimize at every point within the network. Because of that, inventory buffers are put in place to cushion and absorb all the obvious conflicts that will arise between these trading partners. You can't help it. If you've got different planners trying to work within their own node, trying to optimize just that piece of the problem. So the potential value realization is therefore trapped within the network due to the sub-optimization. The stale data, and we've been dealing with stale data for a long time, but no one cares, because the technology that we've had access to can't do anything with anything other than the stale data, because basically we're doing weekly planning with maybe daily adjustments. We're not really reacting on a daily basis to exceptions and problems and solving them. That's why we need all these buffers. The inventory buffers, the capacity buffers, the expediting from a transportation perspective. But really the market hasn't cared that much, because why worry about having real-time data, real-time access, and real representation within the network if we don't really have an architecture that can do much with it? But now that we have this architecture, this network operating model, and we have artificial intelligence that can combine with that model and start to handle some of these larger volumes, now we can really get at it. So now all of a sudden, the fact that all the old monolithic ERP architectures are designed around stale data and batch processing, all of a sudden we look at that and go, hey, wait a minute, there's a better way here. And so in the end, the inventory and capacity buffering is required with what we've been doing, along with increased transportation logistics costs. If you don't do that, then you're going to risk a customer service issue, and we can't have that. So the problem's still there, and we need and this combined network and AI approach needs to solve this problem. So then we want to look at, well, what's the value of solving the problem? And about a year ago, McKinsey put out a pretty good piece called Supply Chain 4.0. And it was around, well, what happens as AI and ML and network operations begin to apply to the supply chain? What's the new potential? Now, of course, this is a vision looking out a few years. But moving from the basic 3.0, which was sort of that old monolithic hub-and-spoke ERP with a bunch of custom stuff on it, moving to a true 4.0, now all of a sudden you have a potential to reduce 75% lost sales, 30% transportation warehousing, 80% supply chain, 75% reduction in inventories, and of course in their piece they go through and explain how all this will occur. But I'll give you a few examples as we finish up today that we're starting to get at these numbers already with some of the deployments we've done by combining network and AI. So this is real. This is happening out there. The other thing that's interesting, if you look at Gartner's piece on the networks and you look at all these features and functions that they include as part of a network business operating model, you recognize them. Why? Well, because we used to depend on ERP for a lot of these. Well, these new network operating models will displace ERP from doing these functions. These functions are done better with trading partners in the network architecture. The ERP can still be used as the system of record for financials. That's what it was designed for initially. We designed ERP initially with financials in mind before we started adding MRP and then trying to do supply chain. But now that we've evolved to supply networks, the architecture really doesn't apply, but still as the system of record for financials, it can be very useful as long as the planning, execution, order management, the transactions go into the network operating model, and then those two can work in concert going forward. So given the value potential breadth of capability now in play, according to these two primary analysts and consultants in the market, I think we do understand that implementing an AI-enabled supply network really is imperative to future success. We have no choice. I mean, as I mentioned, there's all the B2C models have already crushed the old traditional models, the Ubers and the Airbnbs, the Alibabas, even Facebook. If you look at media, this is an imperative. Now, looking at the AI itself, and I'll do a follow-on for those of you that are interested in more depth on machine learning algorithms, things we're doing with random forest and other capabilities, boosted gradients, others. I'll do one in the future that'll compare the predictive results that we're getting between what's happening on the ML side with increased features and vectors on the data and their predictive outcomes as compared to some of the more traditional approaches. We have been getting some pretty good results there. In this particular webinar, I want to talk more about value in the supply network by applying AI to the network. But later, I'm a mathematician myself. In a later webinar, we'll delve into some of those things. But on the surface, I wanted to talk a little bit about some of the mathematical components we have access to here within this AI framework. So first, the rule-based engines, AI, as was mentioned earlier, it's sort of at MIT they called it a suitcase term, but I figured that was a little outdated, so I call it a duffel bag term. So there's quite a bit of things, I guess, that go into this. You know, everyone's calling this, that, and the other thing AI these days, right? So now rule-based engines tend to fall into the duffel bag. And we use them. We've been using them a long time. Now, we do use them in network operations today. When we're looking at solving problems or exceptions, we want to have capabilities to do alternate sourcing. We want to do substitute parts. That's what's considered to be rule-based. So that'll still be in there. Those will be in as part of the intelligent agents that we're going to deploy through AI. We've still got heuristics. We still run netting algorithms between demand and supply. We want to apply capacity constraints to the netting, so the heuristics will still be there. We've still got algorithms. There's different types of optimization that we're going to do. We always have the quest for optimizing the highest customer service levels at the lowest possible cost. There's different types of regressions, logistics, linear regressions, those things. So that'll be in as part of the algorithms. The robotic process automation, that's a higher level of AI. It's becoming very prevalent. We use it constantly because as you get closer to real time, not just where you're doing planning anymore, but now that you have multi-party representation within the network, now we're in execution pretty much almost to where the items are being consumed by the end demand, getting visibility to exceptions not only within a few days, but even within the day, and being able to react to exceptions and problems. You need to be able to automate those workflows and make them somewhat autonomous from a decision-making perspective through AI. And so your robotic process automation will coordinate with intelligent agents across these mathematics, across the rule-based, the heuristics, the algorithms. Now, certain types of exceptions and problems will still be pushed up to the planners. You'll have them in your workbenches and your dashboards. But others you can run in an autonomous fashion, automatically solve for them based on how you want the math here to operate, and then have it report its results to the dashboard so you can make sure it's working okay. Nothing black box, everything open, white box, full access to it. Then you've got the machine learning, and we've started to delve into machine learning fairly heavily in terms of the algorithms we're applying. And then you've got the deep learning itself, where you're starting to get into pattern recognition and dealing with neural networks. And what we're doing there, and I think this is extremely valuable, is because we have such depth in applying different mathematics to solving problems, whether it's rule-based, heuristics, or algorithm-based, what we're actually able to do now is go into those problem areas with our machine learning and neural network algorithms and determine whether there's a better math approach for solving the same problem. So are we able to generate better predictive results by applying machine learning to one of the problems we've been solving with heuristics? A good example there would be around demand planning and forecasting, because around machine learning, you can bring in new vectors, features and vectors that machine learning requires from a data perspective, which could include areas in weather, transportation issues, and so forth, traffic patterns. And the machine learning can uncover new patterns that maybe we didn't code in as part of our heuristic. And all of a sudden now we've got a better approach to that problem. So this is really, really good. This is important because this explains how machine learning is going to be applied to real problems, real solutions, and be used where appropriate, where it can generate better results, as long as there are material improvements over what we've had in the past. Now, we have quite a few intelligent agents available already, as I just mentioned. We've been at this for a while now. The company itself, we've had a network business operating model for many years, but it's really this application of AI and the intelligent agents and the autonomous operation in as part of that really brings that to life. That's why it's so exciting right now in terms of what's happening in the market. So all the agents are already in play. As I mentioned earlier, a lot of the customers that we have, once they get their arms around the network operating model, begin to realize that I'll use the network environment, the multi-party transaction environment, and I'll execute these functions within that environment rather than try to extend the hub and spoke ERP to do this across multiple trading partners, because it just doesn't provide the level of visibility and the level of exception and problem management that's required to unlock the value, because you really need to get down to that near real-time visibility and execution control within the network, and that's why you need the multi-party visibility, the multi-party transactions, the many-to-many architecture, not the one-to-many. So these agents are already deployed and working within the environment. So whether you're looking at forecasting, you're looking at allocations, you're looking at supply and replenishment, we're looking at any of the order promising, how we're going to do sourcing, the transportation, all the material and capacity planning, shipment prioritizations, and so forth. These are all available and working today as part of an agent environment, autonomous agents, AI-based across the network. Now, the way a lot of this has been rolled out to date and the way it's been positioned in the market is through control towers. And so I wanted to give you that perspective because given the current system architectures that many companies are running, as I said, mainly a lot of ERP, and if you're a tier 1 with a lot of custom, trying to solve some of these network problems, and for the most part unsuccessfully. What we're trying to do now is figure out, well, how do we move forward? And so if you use the control tower metaphor, what a lot of the companies have done is they've started to drop into visibility and alerts. Okay, so what you've done is you've gone in and said, okay, what I'm going to do is get the representation square. So at least for the network participants, as I go up through distribution and tier 1 and tier 2 and the warehousing and the regional DCs and transportation, logistics, and everything else, and I start to represent that within the network, and I get visibility to it. And now I get alerts. I begin to understand when the exception's occurring, hopefully as close as possible to near real time as I can get. And I begin to understand where the exceptions are going to occur, where the problems are going to be, and understand that I've been buffering for those problems through additional inventory, through additional capacity, through all these expediting costs. And now I want to solve that a different way. Rather than have all that trapped value in the network, I want the software, the AI tools, the network, the many-to-many architecture to allow me to access the network to solve those problems in a different way, using technology rather than using expense in the forms of capacity, inventory, and expediting to solve the problem, because that's too expensive. We can't afford to continue to do that, and at the same time, I can get better customer service levels, I can get better stocking levels, I can get better mix. It solves a lot of problems and actually one-ups the performance of what we're trying to deal with today. So as we get to level 3, the companies, as they get into decision support, begin to make the decision, how much AI do I want to apply to the decision support? How much do I want pushed to the workbenches and the dashboards for my planners? And then as they get to level 4, where am I comfortable making autonomous decisions? Now, as you get closer to real time within a network, if you have good participation across the network, and this would mean your suppliers, your transportation logistics providers, your carriers, your customers, and so forth, the volumes will increase quite a bit, because once you're dealing with execution, your transactions, your orders, all your stocking locations, it can be in the millions. Now all of a sudden you've got a volumetric issue, but you want to solve for the volume in order to reduce the water, all the protection you have in order to expose the value. And so it's that level 4, the autonomous level with the agents and the AI, that's going to allow you to do that. And we've been very successful in starting to roll that out to some of our customers. Now, how the agents work within a control tower, first you have the tunable system of control. And it's a fact that the enterprise systems today are still going to be there for a while as the market makes this transition to network operating architectures. And so you need a tunable system of control. We need to decide what we raise up to be managed as part of the network environment and what we still manage as part of the original system of record environment on the old hub and spoke system. So a tunable system of control that allows us to go in and go after the biggest business value opportunities first within the network, and then layer one on top of the other on top of the other is certainly a recipe for success. And so the architecture needs to comprehend that so that the two environments can interoperate. And we certainly have that as part of the architecture. Next, you need state machines and tracking events. As you start to go across the network, you've got to know the state, because if you're going with a single version of the truth from a demand perspective, and now you're relaying that signal version of the truth in real time to all network participants, so no one's second-guessing each other anymore. You don't have all this sub-optimization going on. Everyone has visibility to the demand signal and understands how to internalize it. You need state machines so that you understand what state each order is in, whether it's a forecast order, whether it's a plan, whether it's been released, whether it's been shipped, and how it's being tracked through the network. You need visibility to all that in real time, right up to receipt. And so the state machines provide that. And so they're critical as part of this network operating environment, this many-to-many environment, along with the tracking events that tell you where everything is, from orders through physical shipments and everything else. Now what you need, though, is milestones. And this is where the alert framework starts to come in from an AI perspective. The milestones then can look forward and predict where there's going to be exceptions now that you've got this level of visibility and representation because you have a true network architecture. You're not trying to limp along with one of these old style hub and spoke architectures. And you're not trying to limp along with just something like EDI, which doesn't allow really, for any collaboration or any of this type of interaction that we're looking for here. And so what the milestones do, it allows you to define within your workflows, within your network, when you expect things to be at a certain stage, when you expect an order to be at a certain stage, when you expect a shipment to be at a certain point in the distribution. And it can project forward whether you're going to miss any of that. That's how you set milestones in here. So once you have your milestones set, now you can have a more sophisticated approach to, and you're also going to have real-time lead times. You're not going to be stuck with all this static lead time stuff that you're forced to in the current systems. Now you're going to have actual lead times. So you know when and where things really are, when and where they're going to be somewhere else. And if that's going to cause you a problem, now you can generate an alert and determine how you're going to handle that. So then the alert will go up into your intelligent decision making and your learning agents. So these agents, it can either be agents that push the alert or the problems up to the workbench or dashboard that your planners will deal with, or you can set it up to be autonomous, as we've discussed earlier. Because remember, the agents are intelligent, they're going to learn, they're cognitive based on the way we've set up the data, and they're learning. And so their predictions and their decisions will get better and better over time. And then finally, I'll show you what a dashboard looks like in terms of how all this is pulled together, in terms of the KPIs, the reports, and the analytics. Now, I also wanted to show you the funnel from a more conventional standpoint, and I want to make sure everyone understands that this interplays your traditional view and how you're used to your day in the life, the week in the life, the month in the life, and how you're running the business, how it interplays with that, because what we're really talking about here is, and again, up at the top, that's not a misprint. That's sales and operations execution. The market now is beginning to realize in these network operating models, I don't have to live with this old S&OP type thing where I'm doing planning and then I'm hoping that the execution can run the plans and I'm protecting for the plans with inventory capacity in case reality varies from what I planned and I can still manage my customer service levels. What we're talking about now from a network perspective is sales and operations execution, where now you have one streamlined flow so that as you get into more real-time visibility, the autonomous operations, the real-time autonomy that I've been discussing, at the bottom of the funnel, which is really the key to the network operations and the applications of the AI and the advanced mathematics, now you learn. And so now when you're going into your quarterly and weekly planning, let's say you want to change your inventory policies. You've gotten more insights, and now you can lower the water on the inventory based on your ability to react to exceptions and problems at the bottom of this funnel. Now you can go ahead. Now you don't want a nervous environment. You can't make too frequent of changes. You want to be careful, make sure there's always a cost benefit there. And one of those things would be your inventory policies, where you'd really only change those, maybe on a monthly basis or even on a quarterly basis. But what you're doing within the agents, within the real-time environment, is you're learning about how much you can really change those inventory policies and start to go after some of those inventory levels, like we saw the potential with what McKinsey had published. And so those planning changes can take place based on what we've learned toward the bottom of this funnel. And then, of course, as we start to look at up at the S&OP, now we can actually plan different capacity levels too, because now we're starting to remove the inventory cushion, which comes out of your planning layer, starting to remove the capacity layer that comes out of your yearly planning layer. And now all of a sudden we're a much more efficient business, where we started to expose the value, and it's all because of what we can do at the real-time layer, which is the new advancement here, the network operating business models combined with the AI. So if you look at it more from a traditional supply chain view, and this is really just a quick graphic just to show you what a conceptual view, I guess, of what it would look like. And our AI agents, we call them NEO, and that's NEO up there in the corner there. And I'll advance this. It's like a mini automation here. But it shows, these would be those agents. So those math-based agents I talked about earlier, the different types of mathematics will apply. around AI with robotic process automation. And so these subnets that work within the overall network will be solving for problems. So if these exceptions occur, they could be hourly, they could be daily, they could be weekly, they could be monthly. We're exposing these now because of this network architecture, and these intelligence agents, these AI-based intelligent agents, are working to solve these problems. So if I've got an issue with a Tier 2 supplier, maybe what I need to do is do some alternate sourcing. NEO will recognize that this has been a problem. You'll either have it set up to be autonomous at this level, or it'll be an interaction on a workbench with a planner. You'll be able to go out and resolve this problem. Now, some of our customers are leapfrogging the entire network and going all the way into the raw material supply to Tier 2. If you look at some of our restaurant customers, they're actually going onto the Chicago Board of Trade and buying futures for beef, because you need to get the capacity that's available from the farmers in order to have the right amount of supply so that you can plan out your full supply chain. And so you're taking positions on futures markets. We're seeing it in automotive and aerospace as well. The automotive companies and the aerospace companies are taking future positions on aluminum and titanium so that they don't have wild price fluctuations as they come in. So you're starting to look at the end demand in these networks actually leapfrogging all the way across. Now, whether they resell that material or they run through contract manufacturing, both of those can be comprehended within this network. And so you're starting to see a lot of different types of activity occurring here when there's problems within the network. Next problem could be maybe that problem didn't get caught. Maybe you didn't have an agent set up to work at Tier 2. You didn't have visibility to it. And so that problem occurred, and then it caused a problem at your regional DC. And so now, luckily, you have a NEO agent there, autonomous agent, working to resolve that problem. And what we may have done there is done some alternate sourcing. In this particular example, it's a hospital, so what they call a clinical cross-reference could have been handled in terms of addressing that problem. But the point here is that you've got these agents, they're working for you within the network. You can tune them for as much autonomy or interaction as you want to make sure that you're resolving all these issues as they occur with a single version of the truth through this network, so that you can expose all the value that's been trapped for years and years based on the way we've been trying to solve the problem in the past. If you look at the volumes, the scales are pretty significant. You've got one of our consumer goods customers, over 4,000 SKUs, 1.5 million customers. They've got 600 distribution and mix centers, 50 plants, 20 countries. Our military contracts that we're running different departments of the military, over 1 million supply chain events are happening on our network per day. Grocery, one of our customers has 2,400 stores, 37 manufacturing plants, 34 DC. I mean, human planners cannot interact at these volumes and these levels. That's why I'm saying, as you move to a network operating model, which is critical, you've got to. You cannot trap the value in the network anymore. We've already seen what's happened in other industries. To the old models, when the new models came on that were able to unlock that value, it killed the old models. So as the markets are moving, and as I said, Gartner's validated it, this is a valid category that they produced a Magic Quadrant on in the last 12 months. So now we need to react to it. We need to recognize that these volumes require an AI approach. You've got to mix the AI and these intelligent and autonomous agents in with the representation we now have within the operating network. So the 8 keys that really form the foundation for what I'm talking about here. And the first one, really, just the access to real-time data. Remember, we've been dealing with stale data. Hasn't been a problem because, if we had better data, there was nothing we could do with it with our old architectures, the EDI stuff and everything else. But the stale data creates poor decision-making. So we need to move away from that. We need access to community multi-party data. So depending on where we are within the network, we want to have visibility forward to the demand. Anyone that's downstream of us, we want to have visibility to them to make sure we're serving them well as their supplier or their distributor. And we want to have visibility upstream. And like we just saw with that little NEO simulation, we need to be able to make decisions when there are exceptions and problems. We need to use the network. We need to flex the network in order to solve the problem quickly so that we can make decisions about that resolution and not have to protect it with all that excess capacity and inventory and expediting and everything else. Support for network-wide objective functions. The network, obviously,
We want to provide the best customer service, lowest possible cost, but that breaks down into other objective functions within the network. So the way the architecture works, it works on subnets, and so there's different levels of multi-party trading transactions that occur within subnets on the network, and so you can tune different objective functions in there to make sure all the decisions being made within the subnetworks support the overall network-wide objective function. So that's really the key there. The decision process must be incremental. I mentioned this earlier. You can't enter nervousness into the decision-making process. So there's always a cost benefit that needs to be considered when making a decision. So when there is an exception or a problem, we need to take a look at it, and in the control tower, this would be in level 2, we push that up and say, okay, there's different ways to solve this problem. If we have it on autonomous, the engine will decide the best resolution to the problem and go ahead and implement that. If the planner's involved, it'll give them choices and they can decide which way to approach it. But it always, in the background, understands that it needs to consider any nervousness that may enter into the network as part of that decision-making process. And when the agents are involved, we have a hierarchical capability within the network, and if you consider it, we really call it a transactional grid. And so there's a horizontal scalability with the transactional grid related to the agents, so there is precedence with some of the agents as to how they solve problems. And so that's already in the logic of the network related to the transactional grid. The other thing in the network, too, is blockchain. Of course, with a lot of the security concerns these days, there might be different levels of blockchain. You might have Ethereum, you might have Hyperledger in there. And the one blockchain that we have, it provides orchestration. We provide cross-chain connectivity. So it's okay if you're running different blockchains within different portions of the network. We can still provide a blockchain layer on top of that through how one network works in order to handle that data and bring it up. So that whole decision process can occur in an unfettered fashion. It must be continuous. Of course, we need a continuous process here for the machine learning algorithms and the ability to produce better and better predictions over time. We need autonomy. As I said earlier, these volumes can be pretty big, so we need autonomy in these engines. And then they must be highly scalable for the volumes that we're dealing with, and the engagement with the users that I said on the dashboard. This is just a little picture just to show, a day in the life. So we have visibility, we've got a predictive issue, we had a stock out, we had a resolution. So you'll have access to these slides later, and this will just show you how that works. And but just wanted to relate it back to, this is a day in the life, and this is something typical now that you'd be able to do with your new architecture. Seems simple, but it requires everything I talked about in order to make it happen. Same thing on the neural networks. Everyone's talking about including weather and traffic patterns and everything else, and we're doing it. Our machine learning algorithms are comprehending all this today. Remember, a lot of the data that's in the data warehouses was really designed for storage and retrieval and reporting. It wasn't designed for machine learning. It doesn't have the right features. You're not able to generate the right vectors. So all that needs to be evolved. And so that's all happening. We're using this right now in our restaurant and food service industries. The NEO agents, all those different math examples I gave you earlier, you can combine those with the agent. You can make your own agents. So in some areas, if you think your rule-based is better, some is heuristics are better, some you've got machine learning or your neural net's better, you can combine these. The NEOs are flexible. We call them neophytes. And those are flexible, and you can design them and deploy them within your network. And so the way it would look is, for instance, you've got your hospital network on the left and all the different things a hospital does. And then you've got its extended network with all the different people that play a role. And this one's really critical, right? I mean, you cannot have a disruption in customer service in a hospital. These are life events here. And so your autonomous and digital agents are running across the network and making all this happen. We've got tremendous healthcare networks deployed on a global basis right now that are doing this today. This stuff really works. And if you look at the dashboard, up in the right-hand corner, that's NEO. So what we want to talk about is a system of engagement here, because of course we've got the intelligence with the agents, we've got the cognitive factors, but the engagement's really important for culture change. And so this shows where NEO has estimated the amount of money it's saved. This is how you're releasing the trapped value. So in the past, as I said, you buffered with capacity, with inventory, with expediting. Now that we have real-time visibility, a single version of the truth, this network operating model, these NEO agents, we're exposing the trapped value. And so that's where this 42K came from in this particular example, that NEO was able to expose that and record that. And that's where the visibility comes in, the system of engagement, so that everyone's comfortable that and you can drill down on this and understand what is NEO doing, where is it making decisions, how is it doing it, so that you're comfortable. And then it also has an interactive environment for problems and alerts for the planners, for the ones that you want to handle directly and you don't want to handle autonomously. You also have unstructured data that you can link to any transaction in the system. That becomes really important when you're doing collaboration with different participants, different trading partners across the network. And you can also have a global view, because some of our networks are on a global basis, and that's what the bottom left shows, is all that's part of the dashboard. And I just addressed the culture change. Even Harvard Business Review is talking about this stuff and talking about the culture. But as I just showed you with the dashboard, you can use the dashboards and the workbenches to handle any of the cultural issues, because the planners know that once they have this real-time access and we're getting rid of all this stale data, the volumes are too great. They can't handle them. And so they need to interoperate with an AI-based capability within the network architecture. And as I said, if you look up top here, it got cut off a little bit here, but I reiterated what I showed you earlier, which was the McKinsey type metrics that were available out there in the marketplace. And these were projected in the future, but if you just look at some of the results we've had already, whether it's restaurant, retail, defense, automotive, as I mentioned, we also have healthcare and hospitals, we're starting to approach some of these numbers already. So don't get left behind on this stuff. The B2C models, like the Ubers, the Airbnbs, they've already crushed the traditional models on the B2C side. This is happening on B2B. You've got Alibaba's coming in there already, and some of the B2B stuff. You really need to consider, rather than pay for tens of millions of dollars to re-implement, let's say something like SAP HANA with all the customization, with the old hub and spoke model on stale data and all that latency. Move part of your business operating environment onto the network and run it there where it belongs, where it's appropriate, where the technology can help you unlock all the trapped value, and then use your ERP for what it was designed for originally, which is your financials. So just a little bit about us. As I said, we've been at the network business for a long time, but it's really this combination of the network with the AI and these autonomous agents that's really starting to bring this thing to life. So that's the big change, and that's why everybody really needs to start to take a harder look at this, whether it's through control towers or jumping directly right into these one of these network operating models. So that concludes my overview. Hopefully it was interesting for everybody.
Absolutely, Joe. Great job.
Any questions and answers?
Absolutely, Joe. Great job. One of the best snapshots of AI fundamentals, what goes into it, how it works, that I've seen to date. And we have a lot of questions actually rolling in, Joe. And to all of our attendees, we are up against a little bit of a time window here. So we're going to get to as many questions as we can today. And if we don't get to your question, we're going to package that question up, move it over to Joe and the One Network team, and they'll get back to you via email. And Joe, one of the questions, and I've always thought of, and as I mentioned to you before we started recording today, we're hearing in all of our publications, we're hearing so much about AI these days. But I really love this question that came off the floor to you, Joe. How we're very deeply siloed with lots of legacy systems, and I'm sure a lot of folks out there are already. So how do we get started moving our organization to an autonomous supply chain? What are those steps we have to take?
Yeah, I think that's a good one. I talked a little bit about the tunable system of control, so we can interoperate with the current legacy systems. And a good way to go would be, and I'll use the control tower metaphor here, is once you have the visibility across the network, so you're able to represent a real network operating environment. The next step a lot of people take is, oh, great, now I want to be able to collaborate with the different people, my trading partners within the network. And a good way to start would be to then move to within that, let's say, the execution window. So when things really start to move across the network, and that's when you hit a lot of these exceptions and problems, and you'd love to be able to resolve them because, as I said, you have all this trapped value that's in there protecting from disruptions, because whatever happens in real life is going to vary from the plan. You can't help it. There's going to be variability. Right. The way we handle that is how you unlock the trapped value. And so the first step would be, hey, let's go ahead and allow the network operating model to handle those orders. So within that 1, 2, 3, 4-day window, let's turn over control of the order management to the network operating environment. That's not going to disrupt the planning I'm doing anyway, because I'll still do my weekly plan based on what's occurred. But now I'm in a network operating environment where I can actually address those exceptions and those problems without having to buffer for it and start to unlock that value. So that's what we call a business release, and you would have a specific value prop for that business release to go ahead and enact that part of the network, and then over time that would just grow and grow as you continue to expand the value opportunity.
Gotcha. No, and as the data, and as the agent gets deeper and deeper into the system. And we had a couple questions, Joe, coming in around an agent, right? How putting that agent to work, and what does that mean, and what does that look like? So there's a question, Joe. If we put in an agent, how do we tell if it's working or not, or if it stops working? How does an end user understand or know that?
Yeah, that's a good question. So I did the dashboard fairly quickly there, but
yes,
that upper right-hand corner with Neo there, that's the drill down for the agent. So the agent is handling disruptions and exceptions. As I mentioned, they can be somewhat volumetric because some of these companies we're dealing with has millions of stocking locations, and there's exceptions all the time that need to be handled. Now, as I said, you have to be careful not to make the system nervous, but the agent knows what it can do and what it can't do within reason so that it's not causing disruption. That's all part of, depending on what math routine we have with the agent. But the visibility then for the savings that are being created are available, and then you can drill down to see, well, what are the agents actually doing? And as I mentioned in the planning funnel, then you can start to learn from that to say, hey, I can start to fine-tune some of the decisions the machine learning algorithms or some of the other heuristics are making, but I can also then raise my game and say, hey, I can put in different inventory policies now when I'm doing my monthly or quarterly planning too, based on what I'm seeing from the agents and the way they've been able to react to some of the problems. I don't need as much protection anymore. I can see my days of supply have stabilized. I don't need as much protection with safety stock anymore. So those are all different ways that we can get visibility to what the agents are doing.
Yeah, absolutely. And Joe, I just popped up that screen to our audience right now as you were just explaining that, and I thought this was just a great look at it. Another question in terms of an agent: does an agent need a separate value prop before we put it in? That was a question from the floor as well. It's another good question.
Yeah, the way we look at the agents, the value prop actually occurs at the day in the life level. So whether it's a day in the life, week in the life, month in the life, quarter in the life, if we're doing the quarterly planning, those are the workflows that count, right? Because that's where we're making decisions about how we're going to run the business and therefore generate the results that we're looking for. And so that's really where the value prop occurs. Now the agents are deployed as part of those workflows. So when we define a day in the life, where appropriate, and this is what I started the whole conversation with, is you need to apply technology to where the problems are. And so where appropriate in those workflows, we'll assign agents to operate at those areas, in those junctures within the trading network, and designed to solve the types of exceptions that come up at those points within the tiers, within the echelons, whatever you want to call them. And so, yeah, that's how they're designed and deployed from a value prop perspective.
Gotcha. That makes a lot of sense. And Joe, I'm going to move over to this control tower slide that you shared with us earlier in your presentations. We do have a couple questions that have rolled in, and I thought they were really good questions from our attendees today. And folks, we do have a couple more minutes left, so this will probably be the last group of questions we'll be able to get to. Now, if we didn't get to your question today, again, as I mentioned before, we're going to package it up, and Joe and the One Network team can get back to you via email. Joe, one of the questions, I thought was interesting for a quick conversation, how far far are most companies from autonomous, or what would you say, like when you go in to engage with a client, what level would you say most are on this control tower scheme or echelon?
I think the slice I talked about earlier, where once we're within that execution window, whereas where a lot of the problems occur and exceptions because nothing ever runs perfectly to plan. It just depends how severe it is and whether you need to make it actionable based on the cost and the value. The deployments we've done to date are all pretty successful in that area. So we've been able to unlock a lot of the value there. But those are the companies that have already deployed a network operating model. I would say for the majority of the market that's still running on some level of a customized ERP instance, they really haven't been able to get there yet because they're still just dealing with averages, gross level numbers, stale data, and so forth. And so what they're doing, I believe, is they're sort of between level 2 and level 3 where they've got visibility. They've got maybe some level to collaborate. A lot of them are still on EDI, which really isn't a collaborative environment. But they're beginning to realize that that's insufficient, and they're starting to put in the framework for collaboration. And then the next step they need to make after that is, well, okay, it's fine to be able to see a problem and collaborate, but I need a solution framework given the volumes I'm starting to deal with now as I get into real-time execution. So that's the transition they're going through right now, is the handover of the network operating model to manage the orders and the plans rather than the old ERP monoliths, which, in today's world just aren't architected properly to do that for anybody.
Right. Hey, Joe, just a quick question too. How long to reach that top level, that autonomous level? If you're just starting now, I mean, what does that usually take time frame wise for our attendees?
Well, we do it by business releases, and so for the portion of the network we'd be looking at, let's say the 1 to 4 day period. So to get after that immediately, because there's a lot of trapped value in that portion and handling those orders and exceptions, we can typically get through that in about a 6-month window to get through that first business release, and then beyond that, you would have subsequent business releases that would go faster and faster because now that you've got the representation correctly modeled within the environment, and then we've got any data that needs to come in as part of the decision-making process and part of the analytics, the subsequent business releases can roll off fairly quickly.
Right, gotcha. Well, Joe Bellini, terrific job, sir. Wonderful job of putting this all into context for us today. We are up against the up against the clock right now. We're going to gather all those questions that have rolled in. We have quite a few. Again, we're going to roll those over to Joe and the One Network team, and they'll be able to get back to you via email. Well, Joe, great job today, sir. Thank you so much.
Oh, thanks, Mike. Appreciate it. You certainly understand the space as well, so thanks for your insights.
Well, yeah, we're all wrapping our minds around it, and we're loving what we're seeing. One step at a time. But I love that fundamental approach you took today. I think that was wonderful. Great job, and we also want to thank the One Network team for making this terrific educational webcast happen today. So thanks to One Network, and also thanks to everybody who attended today. Thanks again, and have a great day.